I am discussing the pulse modulation. What is the need for pulse modulation? Many signal in modern communication systems are digital. Also, analog system signals are transmitted digitally. Reduce distortion and improvement in signal to noise ratio. PAM, that is abbreviation of pulse amplitude modulation. PWM, that is the abbreviation of pulse width modulation. PPM, pulse position modulation. PCM, pulse code modulation, and DM, that is the delta modulation. In continuous wave modulation scheme, some parameters of modulated wave varies continuously with message. Just an example of amplitude modulation, where the amplitude of the carrier is varied in accordance to the instantaneous value of the modulating signal or the message signal. In analog pulse modulation scheme, some parameter of each pulse is modulated by a particular sample value of the message. Pulse modulation are two types. One is the analog pulse modulation, that is the pulse amplitude modulation, pulse width modulation, and pulse position modulation. Digital pulse modulation is the pulse code modulation and the delta modulation. This is a brief about the pulse modulation. This is the signal. According to the signal amplitude, the pulse width is pulse amplitude is varying. Here the pulse amplitude is varying. When the amplitude of the signal, message signal, this is the message signal. When the amplitude of the message signal is high, according to the message amplitude, the pulse amplitude is also high. When amplitude is low, pulse amplitude is low. This is the PAM, pulse amplitude modulation. This is the pulse width modulation. Here the pulse width in x direction. Pulse width is varied in accordance to the instantaneous value of message signal. So here pulse width is high as the amplitude of the message is high, and the pulse width is minimum as the amplitude is minimum. So the width of the pulse actually carrying the signal, carrying the information about the message. Now the pulse position modulation. That is, in a pulse there are two ways. One is the leading edge, another is the trailing edge. When the pulse width is varying, the edge also changing. This is the leading edge, this is the trailing edge. This is the leading edge, this is the trailing edge. So if pulse width is vary, in accordance to the position of the pulse also vary, or we can say the leading edge and trailing edge position of the pulse is also vary. That is nothing but a pulse position modulation. This is done by the differentiating the pulse width modulation. Here is the pulse code modulation. Pulse code modulation is slightly different from the previous modulation. All the above modulation technique just describes the analog pulse modulation or the analog, and this is the digital pulse modulation, pulse code modulation. Here the pulse, the signal amplitude is or information is transmitted by the terms of digitals, and this is on another type of digital pulse modulation is the delta modulation, which will be I describes it elaborately in my later lecture. Now the pulse amplitude pulse modulation, carrier is the train of pulse. Example, pulse amplitude modulation, pulse width modulation, and pulse position modulation. Types of modulation, I already described about the types of modulation. Here is some brief about the pulse amplitude modulation. The amplitude of the pulse is varied in accordance to the instantaneous value of the message signal. When the message signal is 0, there is no pulse. As the message signal increases, when the message signal is high, the pulse is high. The PM, how the PM generated or pulse amplitude modulation generates. This is done by simply, this is the modulating signal and this is the clock signal. Both are applied to a base of a transistor, and then we get according to suitable bias, we get the output from the emitter. This is the emitter follower type of structure. The circuit is a simple emitter follower. In the absence of clock signal, the output follows the input. The modulating signal is applied to the input signal as also the carrier, or here carrier is the clock pulse. The amplitude of the clock is chosen high level, or is at ground, and low level as the negative voltage sufficient to bring the transistor to cut-off region. Thus, when the clock signal is low, transistor is cut off, the output is 0. Thus, the output of the desired PAM signal. So, PAM is generated simply by a transistor only, and this is the carrier pulse, and this is the modulating signal, and this is the emitter follower type structure, and we getting the output from the emitter. Thank you. This is my first lecture of pulse modulation